Bismillahirrahmanirrahim. Assalamualaikum and hi, my name is Yasmin binti Ajid, matrix number 1714422. I'm here to present on my final year project 1 entitled Low Cement Content of Self-Compacting Concrete using Eggshell Ash and Rice Husk Ash as partial cement replacement. Before I begin, I would like to express my special thanks of gratitude to all those who have supported me directly or indirectly during the completion of this project. To begin, this presentation consists of 4 parts, which are introduction, literature review, proposed methodology, and lastly, conclusion. Self-compacting concrete (SCC), also known as self-consolidation concrete, means it can be placed easily and consolidated by its gravity in a formwork. Using this, SCC gives benefits on fast construction, noise reduction, energy effectiveness, and good formability. Thus, it is an example of technological innovation to produce new types of structural elements with more complex shapes, which were not possible to produce with traditional concrete. Concrete has been used widely as a construction material in the world. SCC is one of the advanced cementitious composites. However, this concrete type of construction costs much higher than regular concrete. As the construction industry grows vigorously, the cement demand also increases by days. Meanwhile, the production of cement creates pollution to the environment such as cement dust, ground vibration, air pollution, waste pollution, water pollution, and noise pollution. The production of cement needs a huge quantity of energy and emits a large amount of carbon dioxide due to the process of calcination. This process releases 0.53 tons of carbon dioxide into the atmosphere to produce 1 ton of Portland cement. The main purpose of these research studies is to show the efficiency of self-compacting concrete with low cement content and eco-friendly material research by determining the optimum percentage of RHA in eggshell ash content as partial cement replacement. Next, it is to evaluate the physical and mechanical properties of SCC by comparing the performance of this concrete using these two materials with conventional concretes. Lastly, to investigate the properties of SCC made of RHA and eggshell ash. Eggshell was chosen as an alternative material to replace cement as according to Akunwu, eggshell consists of calcium compounds which are very similar to cement, which is 93.7% of calcium carbonate content, while RHA contain high amount of amorphous silica which can enhance pozzolanic reactivity of cement. To determine the most optimum percentage of RHA in eggshell to be mixed into the SCC, an analysis of comparing the performance of concrete mixed with this material has been made from various research studies conducted. This table shows the result of average slump value using different percentage of RHA. As we can see here, the average slump shows the highest value when using 20% of RHA to 80% of cement. This table shows compressive strength obtained from the different percentage of RHA used in various studies conducted. You can see here 20% of RHA produced the highest compressive strength at 28 days. Meanwhile, comparing tensile strength obtained, normal concrete, which made of 100% of cement, shows the highest tensile strength at 28 days compared to the concrete with RHA. For eggshell, this material has not been used as cement replacement widely. Only a few results can be found in recent studies. The comparison can be made from the result of compressive strength tests obtained from 2 different studies. Study done by Afizah Asman shows that 6% of eggshell ash create the highest compressive strength at 7 days curing. There are several limitations that can be found from the previous studies. Firstly, there is no research which had done non-destructive tests. Next, eggshell ash had not been used widely and only a few studies had tests on this material with concrete. Besides, all of these studies used conventional concretes. None of them had tried on self-compacting concrete, so less information can be gathered on how much the optimal percentage of RHA in eggshell ash that are suitable to replace cement in SCC. Therefore, in this research, aggregate material testings and non-destructive tests will be conducted to gather more knowledge on the factors that influence SCC performance. From the comparison, it can be concluded that a higher percentage of RHA in Eggshell used as cement replacement create a better performance in terms of physical properties. However, to a higher percentage of both materials reduce the concrete strength. Therefore, from this review, a proposed table had been produced to show the best percentage of RHA in Eggshell ash that is suitable and most convenient to be used in this research. A normal self-compacting concrete sample based on grade 30 will be produced as a control mix, which uses 100% of Portland cement without any additive. Another 3 samples concrete mix will be prepared, which consists of different percentage of RHA and eggshell ash. Methodology that will be involved in producing SCC with low cement content had been identified, starting from collecting of additive materials, preparing the SCC mix, carrying out physical and mechanical tests on these 4 samples until obtaining results for analysis. Now let's go briefly on each step. Firstly, eggshell will be collected from closed cafeterias, incinerated at 100 degrees Celsius, ground and sieved through 75 micrometer sieve, while the RHA will be obtained from supplier which had been burned and ground. Next, mix design will be calculated in designing SCC with characteristic compressive strength at 30 MPa at 28 days. Equipment and other material will be prepared from IIUM Concrete Lab. Then several tests will be conducted, which will be aggregate material tests, fresh concrete test, and hardened concrete test. Lastly, all results will be recorded and analysis will be done to identify which sample contain RHA and eggshell ash will create the best SCC performance. Aggregate properties are one of the factors that influence concrete properties produced. Thus, to obtain the most optimum SCC performance, several material tests on aggregate will be carried out, such as sieve analysis, flakiness index, and specific gravity and absorption of coarse aggregates. In the beginning, sieve analysis will be done according to British standard to identify particle size distribution, while flakiness index purpose to determine the shape of aggregate used, and lastly, specific gravity will be carried out according to ASTM class 127. After mixing for every sample, the fresh concrete will be tested for slump flow to measure the workability in terms of filling ability and consistency of the fresh concrete mix produced before it is set. Non-destructive testing will be conducted on all of the specimens. Using ultrasonic pulse velocity tests can assess the strength of the concrete and detect any presence of damage mechanisms such as cracks. After conducting NDT tests, the hardened concrete samples will be tested for compressive strength test. This test is to determine whether the concrete can resist to failure under any action of the compressive forces, such as cracks or deflection. Hence, it is important to determine the performance of the material during service condition. In summary, the main objective of this final year project 1, which is to propose the optimum percentage of RHA in eggshell ash content as partial cement replacement, has been accomplished, along with all other objectives. Another purpose has also been achieved, which is to collect as many information from various sources, previous studies, and research. Besides, important material for making this SCC, including its characteristics and performance, had been recognized. Next, 2 types of additive materials have been identified to be among the effective materials to replace cement usage in producing concrete. Lastly, the methods of producing SCC with these 2 materials, RHA and eggshell ash, managed to be determined, including the experimental testing, to evaluate the SCC performance. This chart has been constructed as a guideline and benchmark for future work to be done in final year project 2. This schedule consists of the planning for the whole process, starting from preparation of mix design calculation until obtaining the result for analysis of self-compacting concrete with low cement content samples. All in all, a future engineer should have determination in seeking knowledge and aiming to become a Muslim extraordinary engineer who will contribute to the Ummah. At the same time, conserve the world environments. Every deed and work should align with an intention to get Allah's pleasure, as mentioned in the Quran. And those who strive in our cause, we will certainly guide them to our path. For verily Allah is with those who do right. Surah Al-Ankabut, verse 69. That's all from me. Thank you.